Nebulas, the cosmic factories that build new stars. Have you ever gazed up at the night sky and wondered about those shimmering, ethereal clouds of light? Those aren't just pretty lights. They're nebulas, the very birthplaces of stars. Nebulas are vast cosmic clouds composed of gas and dust, scattered across unimaginable distances. Within these stellar nurseries, gravity and time conspire to create the next generation of stars. These celestial wonders are not only visually stunning, but also offer us invaluable insights into the fundamental processes of star formation. Join us as we explore these cosmic factories. What exactly are these nebulas made of? The primary ingredients are hydrogen and helium, the simplest and most abundant elements in the universe. But it's not just hydrogen and helium. Nebulas also contain traces of heavier elements like carbon, oxygen, and nitrogen, forged in the hearts of dying stars. Interspersed within the gas are tiny dust particles and complex molecules, all swirling together in a cosmic dance. This material is spread across light years of space, an immense reservoir of raw material. All of this material is the very stuff from which new stars are born. It's a cosmic recycling process on a grand scale. So how does a nebula transform into a star? It all starts with a trigger, a cosmic event that initiates the collapse of the gas and dust. This trigger could be a shockwave from a nearby supernova, the explosive death of a massive star. Or perhaps the gravitational influence of a passing star nudges the nebula into action. Even the collision of two nebulae can set off this spectacular chain of events. Once triggered, gravity takes over. The gas and dust begin to collapse inward, drawn together by their mutual gravitational attraction. As the material collapses, it begins to spin, much like water swirling down a drain. This spinning motion causes the material to flatten into a rotating disk. At the center of this disk, a protostar begins to form. The protostar is a baby star, not yet hot enough to ignite nuclear fusion. It continues to accrete material from the surrounding disk, growing in mass and temperature. As the protostar grows, it clears away much of the surrounding gas and dust. Eventually, the core of the protostar becomes hot and dense enough to initiate nuclear fusion. This is the moment of ignition, the birth of a star. Hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy in the process. This energy counteracts the force of gravity, stabilizing the star and preventing further collapse. A new star is born, shining brightly in the cosmos. Nebulas aren't just passive bystanders in the star formation process. They actively shape and influence the birth of stars. The radiation and stellar winds from newly formed stars sculpt the surrounding nebula, creating intricate patterns and structures. These interactions can trigger further star formation in other regions of the nebula. This can lead to the birth of star clusters, groups of stars born from the same nebula. It's a dynamic and interconnected process, a cosmic ballet of creation and destruction. The nebula is not just a womb, it's an active participant in the birth of its stellar offspring. Nebulas come in a variety of shapes and sizes, each with its own unique characteristics. They can be broadly classified into three main types: emission nebulas, reflection nebulas, and dark nebulas. Emission nebulas are perhaps the most visually striking. They glow with vibrant colors, the result of ionized gas emitting light. This ionization is caused by the intense ultraviolet radiation from nearby hot stars. The UV radiation strips electrons from the gas atoms, and when these electrons recombine, they emit light at specific wavelengths. This is why emission nebulas often appear red, due to the strong emission of hydrogen alpha light. Reflection nebulas, on the other hand, don't emit their own light. Instead, they reflect the light of nearby stars. These nebulas appear blue because blue light is more easily scattered by the dust particles in the nebula. This is the same reason why our sky appears blue during the day. Dark nebulas are the opposite of emission and reflection nebulas. They are dense clouds of dust that absorb and block light from behind. They appear as dark patches against the background of stars or other nebulas. These dark nebulas are often the sites of active star formation, hiding the nascent stars within their dusty depths. Each type of nebula plays a crucial role in the cosmic ecosystem. Studying nebulas is essential for understanding the life cycle of stars. They provide us with a window into the processes that govern star formation, from the initial collapse of gas and dust to the ignition of nuclear fusion. By analyzing the light emitted from nebulas, we can determine their composition and physical conditions. This allows us to understand the building blocks of stars and the universe itself. Nebulas also provide clues about the formation and evolution of galaxies. They are the sites where new stars are born, which in turn influences the structure and dynamics of galaxies. The study of nebulas is a testament to the dynamic nature of the cosmos. They are constantly changing and evolving, shaped by the forces of gravity, radiation, and stellar winds. They showcase the beauty and power of cosmic factories where stars are born and the universe is enriched with new elements. By studying nebulas, we gain a deeper appreciation for the vastness and complexity of the universe. We begin to understand our place within this grand cosmic tapestry. So the next time you gaze up at the night sky, remember the nebulas. Remember that these shimmering clouds of gas and dust are not just pretty lights. They are the birthplaces of stars, the cosmic factories that build the universe as we know it.